Motion and speed between objects. You are going to complete this with the little booklet that was given to you today during class. Motion is when something you're looking at is moving and you are relating it to an object not moving. In your text box, the little box on your paper, I want you to draw a picture of something that you think is in constant motion, meaning it does not stop what it's doing. Like the little red guy with the hat on, he is in constant motion in our video. Reference points are where an object appears to not be moving. Sometimes reference points are moving and sometimes they are not moving. So for example, if you told somebody to turn right at the big blue house, that would be a non-moving object. And if you told somebody else that your relationship to a speeding car versus another speeding car, so you're trying to see how fast you're going, that would be a moving reference point. Earth is our most common reference point because it's obviously where we live, and it is in motion, you just don't feel it because you're so teeny tiny. All right, in your text box, I want you to describe why you think Earth is the most common reference point when giving directions. This should be really, really easy. Motion is, definition, an object in motion has speed in relation to a reference point. So in this text box, I want you to illustrate something that needs some form of energy to begin its motion. So it needs a push or a pull, which is your definition of force, in order to begin its motion. So think about something that has to be pushed or pulled, nothing that's battery operated. So think about something that's got to be in motion with a push or a pull. Velocity. All right, motion occurs when an object changes position over time when compared with the reference point. Velocity is when a direction is added. All it is a speed with a direction. So you add north, east, south, or west. This is some type of a speed, so 5 miles per hour is a speed. 5 miles per hour north is a velocity. It's the only change. So in your text box on your paper, I want you to label arrows with a north, east, south, and west location. So velocity definition, speed in a direction. That's all it is. There's nothing you need to do different to calculate it. There's nothing you need to do different to calculate distance or time when you have velocity. You're just adding some form of a direction. So now illustrate something with a velocity and explain your picture within the text box. You may want to write in your definition first, which is right below, and then do your text box. When you're showing me your illustration, make sure you add some form of a marker with a direction. So you're telling me that the airplane is traveling north, if that's what you're going to be drawing. Speed triangle, we've used these quite a bit. You need to draw your speed triangle from your notes. Make sure you label the distance with the D, the S for speed, and the T for time. Okay, right now at this moment, I want you to stand up and I want you to do 10 jumping jacks and get your blood moving. All right, units for speed. In the box, you're going to work out the following speed problem using correct units. You're going to write big in the box so you can see your work. Some of you write really, really small. You know who you are, and make sure it's legible. So here's Wally the worm, covering 16 centimeters in 4.5 minutes in a hard clay soil. What is Wally's speed as he digs his way through the clay soil? Make sure you show how your problem is set up. Make sure you show your correct units from the problem, and make sure that you make sure your answer is correct as well. So the last thing that you're going to answer says, where do the units come from? The centimeter unit comes from the distance traveled, and the seconds comes from the time it takes to travel that distance. This is your stopping point. If you need to go back and review, you can. At this time, please make sure all of your answers have been answered in your little booklet and be ready for class tomorrow. Oh, by the way, if you're still doing jumping jacks,